Alright, we are on problem number 4 in section 13.3, concavity. So again, we're given a function and we're given the second derivative. So the function is f of x equals x squared over x minus 1 squared. And the second derivative is 2 times 2x times 2x minus plus 1 over x minus 1 to the 4th power. Alright, so we need to determine the point of concavity and the points, the potential points of inflection. Sorry, I said points of concavity, I meant just the concavity over certain intervals between the points, between the candidates for points of inflection. And also points where the derivative is not defined. The second derivative is not defined. So the second derivative is not defined in x equals 1. And the function is not continuous at that point either. So the point cannot be an inflection point, but the nature of the graph does potentially change on either side of this point. So it's important to examine the intervals between those points, that point. And let me see. So f prime of x, f double prime of x, the second derivative is 0 when x equals negative 1/2. From the top portion of the second derivative. So we have negative 1/2. So the intervals are going to be from negative infinity to negative 1/2. And then we have negative 1/2 to 1. And then we have 1 to infinity. So we need to examine the various components of the second derivative in all the intervals. So we have 2x plus 1. And then we have x minus 1 to the 4th power. And then that'll tell us the sign of the second derivative, and then we can determine the nature of the function f of x in those intervals. Alright, so let's start with the first interval from negative 1/2 to negative infinity. So let's plug in negative 1. That's going to give us negative 1 for the first component of the second derivative, so that'll be negative. Plugging in negative 1 into this second component, the denominator, that will get us a positive. And so the second derivative is going to be negative. That means the function will be concave down in the interval between negative infinity to negative 1/2. Moving on to the second interval between negative 1/2 and 1, let's plug in 0. 0 plus 1 is positive. 0 minus 1, that's going to be negative, plus to the 4th power will be positive. And so the second derivative will be positive. And thus the function will be concave up from the interval negative 1/2 to 1. finally, we'll look at the interval after 1, from 1 to infinity. So plugging in 2, that's going to get us a positive value up here. And 2 minus 1, that's going to give us a positive value here. That means f double prime of x is also positive. That means the function is still concave up after 1, and so there's no change in concavity. And that's all we really needed to say there, because 1 is not a candidate for an inflection point, because the original function is not continuous at that point. And so we just need to establish the nature of the behavior of the function between that number, between 1, and we have, and so we're done. The only thing that needs to be pointed out is that negative 1/2 is an inflection point. Because again, the graph changes from concave down to concave up as it passes through that point. And we are done with this problem.